Okay, hello everyone. Welcome back with me, Farhan Setiawan from uh, Mechanics Fluids class 3, and my NPM is 2208248110. And today we are going to dive into the world of fluids and learn about the fundamental principles that govern their behavior, from the way they flow and the force they act upon them. We'll cover it all in this video. So let's go start. Okay, as you know, fluids are around us. They are substances that flow and change shape in response to force and pressure. From the water we drink to the oil in our cars, fluids play a crucial role in many aspects of our daily lives. But have you ever stopped to think about their work? Uh, Today, I'm gonna I'm gonna tell us about my consciousness to this video. Yes, my consciousness is a fundamental aspect of human existence, encompassing our subjective experience of the world and our ability to perceive, process, and respond to stimulate. It is a foundation upon which our thoughts, emotions, and actions are built. Understanding a consciousness is crucial for learning and praying to God. Is it always allows us to develop a deeper connections with the divine and cultivate a more meaningful spiritual practice. This consistency was essential for learning as it allows us to focus on new information, process it, and retain it. By cultivate self-awareness and attention, we can improve our ability to learn and absorb new knowledge. And now, I'm on my consciousness. Okay. Uh, there's quotes from James Clear in their book about atomic habits that you don't have to be victim of your environment. You can also be the architect of it. So, next, we'll explore the key concepts and principles that govern behaviors of fluids. We'll discuss about differential types of fluids, the force that act upon them, and the ways in which they interact of their surroundings. By the end of this video, you'll have to solid understanding of the basics of fluid mechanics and be able to apply knowledge the real world problems. Okay. Uh, Through the intention, as I sit down to delve into fascinating world of fluid mechanics, I am filled with a sense of purpose and determination. I intend to thoroughly explore the integrates of the field of fluid mechanics, which play such a crucial role understanding various phenomena in our daily life. From the flow of water in rivers to the circulation of our blood in veins, fluid mechanics is essential for grasping the underlying principles that govern this process. Before I begin, I take a moment to reflect on the importance of the subjects and the potential benefit it holds. Yes, also take a moment to pray, seeking guidance and wisdom as I embark on his learning journey. I pray that I may be able to grasp the concepts and principles of fluid mechanics with clarity and precision, and that I may able to apply them effectively in my future endeavors. So my initial thinkings about fluids mechanics, the fluids are substances that can flow and change shape in response to force applied to them. This is in contrast to solids which maintain their shapes to and resist deformations under force. The properties of fluids that first have several key properties that are crucial to understanding their behavior. This includes viscosity, compressibility, and surface tension. Viscosity is the measure of the fluid's resistance to flow, while compressibility refers to how much a fluid can be compressed. The application of fluid mechanics has a numerous applications across various engineering disciplines. For instance, aerospace engineering study aerodynamics and propulsion systems, while civil engineering design systems for water and flow and drainage. Mechanical engineering uses fluid dynamics principle in design pumps, compressors, and heating and air conditioning equipment. And electrical and computer engineers also use fluids in data storage and other applications. So, my utilization is first I'm gonna explain about conservations about mass, the states of any system close to all transfer of matter and energy to mass must remain constant over time. Secondly, about Bernoulli equations that says states for any system close to all transfers of matter and energy they must remain constant over time. Lastly is the fluid mechanics. These help engineers and researchers understand the behavior of fluids in different scenarios and develop solutions to practical problems. The instructions to learn about fluid mechanics is the essential the essentials to understand the fundamental principles and concepts that govern the behavior of fluids. Start by the understanding the definition and types of fluids, including liquids, gas, and plasmas, as well as basic laws of fluids mechanics, such as the conservation of mass, momentum, and energy, and the second law of thermodynamics. Next, the study fluid statics, including hydrostatic pressure, buoyancy, and the shape of fluids in surface containers, which is crucial for many applications such as hydraulics and engineering. Then learn about the force that act on fluid motion, including friction, viscosity, turbulence, and understand different types of fluid flow, such as laminar and turbulent flow, and how they are described using the Eulerian and Langerian methods. Engage in hands-on experience to measure fluid properties like viscosity, density, and pressure, which will help you to develop a deeper understanding of the underlying principles and their applications. Explore real-world examples of fluid mechanics in action, such as designs water clock, meters, and aircraft performance, to see how the principles of fluid mechanics are applied in various fields, including engineering, aerospace, and biomedical science. Finally, learn how to use mathematical models and numerical methods to solve fluid dynamic problems, which involve understanding the governing equations and using computational fluids to simulate analyze fluid flow. I'm gonna talk about the conservation of mass, basic knowledge to that the conservation mass is a fundamental principles in fluid mechanics that states that mass cannot be created or destroyed within a system. The principle is based on the idea that the total mass of a system remains constant over time as long as there are no external source or sinks of mass. The conservation of mass is a key concept in understanding the behavior of fluids and is used extensively in various applications, including fluid flow, heat transfer, and mass transport. The conservation of mass can be mathematically represented using the continuity equations, which is a statement of mass conservation. For incompressible fluids, the continuity equation is given by delta P uh, divided by delta T plus volume times rho times U. Equals to zero. The equation states that the rate of change of mass within a control volume is equal to the net mass flux into our out of the control volume. Next, about the Bernoulli equations. That Bernoulli equations is a fundamental concept in fluid mechanics that relates the pressure, velocity, and height of fluid in motions. It is mathematical represents of the conservation of energy principles and is widely used to analyze behavior of fluids in various applications. The Bernoulli equation is separately written as P1 plus uh, rho times V1 quadrat divided by 2 plus rho times gravity times height 1 equals to P2 plus rho times velocity 2 quadrat divided by 2 plus rho times gravity times h2. This is a case problems about a fluids mechanics applications that this case is explained as air at 40 Celsius flows steadily through the pipe shown in the figure. If P1 is 40 kPa, uh, P2 equals to 10 kPa in gauge. With the diameter is 3, the diameter PATM is 100 kPa. The average velocity at section 2 is velocity 2 equals to 24 meter per second, and as temperature remains nearly constant, determine the average speed at sections 1. The average speed at section 1 is determined to be as some solve about this problem that the to determine the average speed of sections, we can use the principal conservation of mass and the Bernoulli equations, and we'll break down the problem into following steps. The first step is apply the principal conservation of mass to relate the velocities at sections 1 and 2. Secondly, use the Bernoulli equations to relate the velocities and pressures at sections 1 and 2. And the last step is solved for the average speed and sections 1 using the obtained relationship. The step 1 is the conservation of mass. That the principal conservation of mass states that the mass flow rate is the constant in a steady flow. Therefore, we can get velocities of the sections in 1 and 2 using these equations, where the A1 and A2 are the cross-sectional areas at the sections 1 and 2, and velocity 1 and velocity 2 are the average velocities of sections 1 and 2 respectively. Step 2 is the Bernoulli equations. That applying Bernoulli equations between sections 1 and 2, we got we have these equations that where the P1 and P2 are the pressures are at sections 1 and 2, and rho is the density of the air. The step 3 is solve for the V1 using the given values and the relationship as obtained from the steps 1 and 2. We can solve for the average speed of sections 1. There's equations, and given that the temperature remains nearly constant, we can use the ideal gas of law to find this density. This density, okay, this density. Now substitute the value at rho back into the expression of V1 to find average speed at sections 1. The average speed at section 1 is determined to be approximately at 16.6 meter per second. Therefore, the average speed at sections 1 is 16.6 meter per second. This is the solve of the case in mechanics fluids problems. I think that's from me from this video and explain about case in mechanics fluids. Okay, wassalamualaikum warahmatullahi wabarakatuh. Bye bye.